Good morning, class. Today is Monday, April 4th, and may the 4th be with you, or the force be with you. Let's get started today back in my kitchen because we have some more notes followed by an engineering challenge and science experiment. There's a lot more going on in the background, which is really upsetting to my dog. So if you hear her bark and you see me quickly scurry away, that's what's up. This is the next page in our Ultimate Science Notebook. We're talking about what is plankton. That's the first note that you're identifying. I think the notes are called "Who Cares About SpongeBob" anyway, but we'll get to that in a second. So the first question we're answering today is, what are plankton? Plankton are so important to us. You might be thinking like what's funny is on SpongeBob, they're the evil characters, as you saw on the bottom of my screen, but really they're the heroes of planet Earth. We would be dead without plankton. I think it's 1 in every 5 breaths we take. 20% of the air we breathe is thanks to plankton. We get a lot of our oxygen through photosynthesis from trees and plants and things like that, but plankton cannot be underestimated. They're super important for giving us oxygen in the atmosphere. We also would be completely without food without plankton. We would be without a cleaner earth without plankton. Global warming would accelerate so much faster. So it's really interesting to me, and that's one of the things I love about environmental science, is that you need to pay attention to all of the important tiny details because those things matter the most sometimes. Okay, so back to this. What is plankton? They actually do kind of look like the plankton that you see on the bottom of my screen that's pictured in SpongeBob. This is a more accurate picture or a scientific depiction of what plankton look like. They have many different shapes and many different forms. The key thing that makes something a plankton is it's a tiny ocean organism that can't swim against a current. They float through the water. They're an important food source for fish and whales. And they're also an important food source for us because we then eat a lot of fish. So a lot of fish that we eat depend on plankton for food, or they eat something that depends on plankton for food. A key word there is they float through the water. They cannot swim against a current. So some zooplankton have the ability to swim just a little bit, but they could never go against a current. So a current is kind of like a strong pull of waves in a certain direction. So they can go with the waves and maybe swim like a little bit, but they cannot go this way against the waves. So this is what your note page looks like. There we go. SpongeBob or plankton, solving the great mysteries of life. What is plankton? So this is the page that you should find in your Ultimate Science Notebook. So the next question we're asking is, where do plankton come from? Some organisms spend their entire lives as plankton, while it is the early stage of life for others. Something that I really want to point out, and your face is going to look just like Patrick and SpongeBob. One particular organism that starts off as a plankton and turns into something else is, wait for it, a starfish. So what's really going to blow your minds is that Patrick from SpongeBob was originally a plankton. So that means that Patrick was at one point a plankton. Keep that in your minds. It's pretty awesome. I know, mind blown. Isn't your face just like that now? Awesome. So there are 3 most important ideas about plankton. Plankton are really super important. That's the first thing you're filling in for that idea 1. Plankton are super important because they are producers, consumers, and decomposers. They affect everything in the ocean. And I want to review a little bit of our ocean songs now, as well as our producers, consumers, and decomposers song. I'm going to move my loud supplies out of the way. I'm living in my ecosystem, yeah, living on living things that I have. I'm happy in my habitat, it's number 1. All energy comes from the sun. There are producers that eat the sunlight, consumers that eat producers, all right, predators that munch on their prey, oh no, and decomposers. They restart the cycle. Oh, my ecosystem's beautiful. Awesome. I want to review our ocean continent song too while we're here and paused. 1, 2, 2.5, 3. I'm heading out to the ocean sea. 70% with high salinity. I'm heading out to the ocean sea. Stop the shelf. The continental shelf of the ocean sea, not too deep, just perfect for me. The continental shelf of the ocean sea, stop the slope. The continental slope of the ocean sea. Water gets deep oh so quickly. The continental slope of the ocean sea. Stop. The rise. My dog is like really staring at me, very confused about what's going on right now. The continental rise of the ocean sea. Bump at the bottom from depositing. The continental rise of the ocean sea. Stop. The abyss. And then we have our ocean zones going from top least salinity to most salinity, least pressure to most pressure, least dense to most dense, most life to least life, most temperature to least temperature. 1, 2, 3. Epola. Adject zone sunlight zone sunlight zone sunlight sunlight zone. Mesopola. Adject zone twilight zone twilight zone twilight twilight zone. Bathypola. Adject zone midnight zone midnight zone midnight midnight zone. Awesome. Let's go back to our note page. So like I said, the first idea is that plankton are super important because they are producers, consumers, and decomposers. Remember, those are the only 3 niches that a living thing can have. Those are the only 3 jobs. So plankton can be producers, meaning they make their own food. They do photosynthesis. They can be consumers, actually eating other phytoplankton or small pieces of food. Or they can be decomposers, which are bacterial plankton that break stuff down. Idea 2. There are 3 types of plankton that fit these 3 specific niches in the ecosystem. Phyto or photoplankton are producers, meaning they do photosynthesis, they get their energy from the sun. In class, what is photosynthesis? Photosynthesis is when plants take in CO2 and H2O and turn it into oxygen and glucose. What is the part that plants need? CO2 and H2O. What is the part that animals need? Oxygen and glucose. So phytoplankton, they do photosynthesis. They get their food from the sun. They are basically like plants, but in the water. These are the guys that give us 1 in 5 breaths on planet Earth. So they're super, super important. All of these plankton pretty much live in the sunlight zone, although pieces of food are always drifting down to the other zones. Zooplankton, so that photo means light, like this. So remember, photo means light, synthesis means change. So photosynthesis means light changing. Phytoplankton or photoplankton are plankton that needs sunlight. So they're the producer plankton. Zooplankton, zoo actually means animal. That's why when you're a zoologist, you study animals. If you are going to a zoological park, or we say zoo for short, you're going to see animals. So zoo means animal. And so with that, we know that zooplankton act more like animals. They are consumers. Bacterial plankton breaks stuff down. This is basically just bacteria that lives in the ocean that is really important, and other animals still eat it. In the same way that we eat decomposers, a lot of people are grossed out by the idea of eating decomposers. There's some really tasty ones out there. I myself love mushrooms, and I have personally eaten snails before, as I talked about in our France section, and both were delicious. So don't be afraid of decomposers. They're really important, not only to our ecosystem, but also to our food source. The third idea about plankton that's really important is that plankton have different adaptations. Remember, an adaptation is something an animal has that helps it to survive. They have 2 main goals in life. Their 2 goals, their only things that they're really focused on in life, is not being eaten and staying in the water. Both of those are a death sentence, obviously, for our plankton. So, getting away from the SpongeBob pictures, these are some of the adaptations that plankton have. This top one is more of a zooplankton because it has those branches out, and this one probably has a little bit more ability to swim. This one also is kind of what the plankton from SpongeBob is modeled after. This one is more of a larvae of a future different animal. This is, I believe, called a diatom. This is what the phytoplankton would look like. And this is kind of what bacterial plankton would look like. All right, so the next thing we're going to do is a plankton lab. And you have, as always, 2 options with any of the labs that we do during this coronavirus time. The first option is I'm going to do this experiment myself. I'm going to call my husband in a second. He's going to help be my second timer or current creator. The other option is you can feel free to do this experiment at home. What you need for this experiment, you need a tray that you would use for cooking filled with a little bit of water. Don't have to be specific about the size of the tray. You don't have to really be specific about the size of the water. We're using a square pan like that you would use for brownies or cake. The other thing you need, and I actually am so bummed because I collect wine corks like all year everywhere I go for the purpose of this lab, because I know I use it all the time. Like I'm always going over places and I'm like, hey, can I have that cork? Because my students will use it. So I'm not condoning the use of drinking alcohol at all, but we are going to use our wine cork. And the reason we're going to use our wine cork is it floats in water kind of naturally. In other words, it is less dense than the water. Remember, in science, whatever's deeper is more dense. So I'm going to do first a test run with one of the wine corks. And then what we're going to do is either with your breath or with a straw, you need to set the wine cork at one end of your cooking tray, and then you are going to personally create the current. Now, if you have a straw, you can use a straw. Otherwise, you can just blow. And your goal is to get the plankton from one side to the other. Now, how does this simulate plankton? How is it different than plankton? So it simulates plankton because most plankton don't have the ability to swim, and no plankton have the ability to swim against the current. So part of the reason we do this lab is to show that plankton have a very specific role in that ecosystem. They don't have a lot of ability to swim, so they need all of these extra spines, they're called, or adaptations. They need all these other pieces of their body to help them direct where they're going and avoid being eaten and staying in the water. Remember, those are the two goals of plankton. They want to stay in the water. They want to not be eaten. So then once you do it with one regular cork, you're going to copy down your design. You're going to record the time it took. You're going to record any observations. So for example, on this first one, I'm noticing that it's spinning all over the place. And so probably with any further adaptations I do, I would want to add things. You can add anything that you have at your house as long as it is not being used for something else, and that you have permission to use it. So I'm going to pause for a second and